Hi, this is a simple demo of how we can use Opera and context engineering to get models to be more reliable and effective by only passing feedback. What you'll notice here is how we can drive instant improvements in reliability and efficiency out of models without the conventional hard work of prompt engineering or fine-tuning. So the way this sample app works is that it's a conventional ChatGPT style chat app with the only difference that you can speak to multiple models at the same time. So basically how it works is you can ask a question, the models you have selected will generate responses, we can provide feedback in the interface through thumbs up or detailed 1 to 5-star ratings. And what will happen here is that Opera will learn from this feedback and tailor subsequent model interactions with the context of this feedback. So I'm gonna show a little bit what the experience of this could be like. So here we have 3 models selected. We have Opus 4.5, the latest anthropic model, super strong. We have probably the best open weight models, GLM 4.5. It's a 1 trillion plus parameter model. And we have a very small open source model from OpenAI, the 20B version, it's the smallest one, out of Grok. So basically what I first want to show you here is a little bit, basically the most simple example we can say, right? So something like an hello message to models, right? What we'll see here is obvious that these 3 models will answer this in a completely different way, because they are post-trained, fine-tuned, to be expressive in a certain way. So that's why we get 3 distinctly different responses here. Also with distinctly different response time, 3.3 seconds for Opus 4.5, this open weight model 1.6 seconds, and GLM 4.5 3.8. And what we can say here is another thing is that if I prompt this again, I will very likely actually get different responses. So we will notice here that Opus has a slightly different, answer, but we have actually sent it the identical set of input tokens. So models, this GLM as well, they're not deterministic, meaning they will, come up with a slight different way of answering the same input tokens or responding or completing the same input tokens. I'm going to talk about some settings here. So history, so every time I ask something here, it's not currently passing any history, which means that we're, engaging the model with 0 context from prior conversation whenever I ask something here. And we have Opera off currently. We're going to enable that in a bit. We have these 3 models, and we have the same system prompt for all of these models. So literally what we're sending these models is this system's prompt, you're a helpful AI assistant, respond, and we're sending it this kind of user message. So we're getting exactly the same thing. We're not going to tailor the system prompt or anything in this demo. So what we can do here is to use context engineering through Opera. So I'm going to enable Opera, which means that Opera's features for taking in feedback and optimizing the model interactions to steer against this feedback will be turned on from here on. So my first kind of task here is to determine what is the style of my chat assistant that I want to promote. So I'm going to thumbs up this one. I think this is short and sweet. I want this kind of basic response, not this overly long that just has a bunch of ideas of what I want to do with it. So I like this GLM 4.5. So what I'll do now is that I'll probe the same question, and again now Opera is on. So with all these model interactions, Opera is going to context engineer the response. So we can see here now that this is much more consistent across the models. There's still some degree of personality in the models. For instance, Opus 4.5 here has a smiley or emoji, but largely they are stylistically the same. And what's interesting with this in-context engineering approach is that it also generalizes. So if I would say something like howdy, we will see that it's still consistent, even though we actually don't have a direct feedback indicating that exactly how to respond to howdy. So we can see that it's consistent across different messages. So now this is a very basic example. So let me try with a more slightly more advanced example, I could do something like list the ingredients of a pasta carbonara. So again, we would get different responses, different length, and different style. Claude wants to do these markdown headings, and I continue to like this GLM 4.5 variant, so I'm going to be using that as feedback. I'm going to turn on Opera again, and I can say, I'm going to copy paste this one. So I'm going to try this exact example again. We can see that we now have lists, much more consistent. They still show personality, but there's no tables or headings or things like that. So stylistically, we're getting the same. We can do something like Bolognese. I don't even know if it's spelled like that. But we can see how it starts with, here are the traditional ingredients, here are the classic ingredients, the traditional ingredients. So we get a very similar style output here. Now, this is a chat, a chat bot. So here we might be more concerned with style and formatting and things like that. And this offers a super neat way of directly affecting, the stylistic output through feedback without doing any, prompt changes or anything. But this kind of behavior that models actually behave differently and are very sensitive to inputs extends from these kind of simple cases with an hello all the way to very advanced agents, right? So the tools that an agent wants to choose, how it's reasoned about trajectory, all of these things are subject to exactly the same things, right? So what we're showing here essentially is, both the problem these models have, like switching between models is very tricky because of these differences in them. And the other thing is that they are also not consistent in themselves, even in the same model. So through this kind of approach of context engineering, meaning that you have a middle layer like Opera that engineers the right tokens to send to the model, by assembling basically data sets and understanding of what great looks like over time, we can drive much better performance and much higher reliability of chatbots and agents and RAG pipelines and whatnot. So this is a simple example of what customers experience using Opera with this kind of approach. Now, feedback can be many things. Now we have a simple thumbs up, thumbs down. It could be something like this, where the kind of feedback is acted on. It could also be rewarding other kinds of, kind of grander application metrics, such as engagement or similar kind of things. It doesn't have to be, thumbs up and thumbs down. There's obviously a decision here to be made also by the application developer, whether you want to expose thumbs up and thumbs down to the end user directly, or if you want some kind of intermediary, state management and process for curating these dataset entries and context engineering. Those are all the things that Opera takes care of, building this kind of engine where the AI assistants, AI agent, AI chatbot becomes really data-driven rather than prompt-driven. Thanks a lot.